Giphy is a search engine for GIFs, the short animated graphics that we see around the internet and in our messaging applications. Giphy is also a creative platform where people create new GIFs. Every search engine requires the construction of a search index, which is a data structure that responds to search queries efficiently. Since Giphy is a search engine for graphics, there is almost no text inherently associated with each document. Giphy uses a pipeline of different labeling techniques in order to make a GIF indexable by the search engine. In my conversation with Giphy CTO Anthony Johnson, we discuss how to scale a search engine. We discuss why Giphy needs to build new techniques for image processing, how human labeling for machine learning is evolving, and the future of Giphy, both as a creative medium and as an advertising platform. This was an exciting and wide-reaching interview, and I think you'll enjoy it. Couchbase is a NoSQL database that powers digital businesses. Developers around the world choose Couchbase for its advantages in data model flexibility, elastic scalability, performance, and 24/365 availability to build enterprise web, mobile, and IoT applications. The Couchbase platform includes Couchbase, Couchbase Lite, which is the first mobile NoSQL database, and Couchbase Sync Gateway. Couchbase is designed for global deployments, with configurable cross-data center replication to increase data locality and availability. Running Couchbase in containers on Docker, Kubernetes, Mesos, or Red Hat OpenShift is easy, and at developer.couchbase.com you can find tutorials on how to build out your Couchbase deployment. All Couchbase products are open source projects. Couchbase customers include industry leaders like AOL, Amadeus, AT&T, Cisco, Comcast, Concur, Disney, Dixons, eBay, General Electric, Marriott, Neiman Marcus, PayPal, Ryanair, Rakuten/Viber, Tesco, Verizon, Wells Fargo, as well as hundreds of other household names. Thanks to Couchbase for being a new sponsor of Software Engineering Daily. We really appreciate it. Anthony Johnson is the CTO of Giphy. Anthony, welcome to Software Engineering Daily.
Hi, I'm looking forward to chatting today.
Absolutely. Giphy is a search engine for GIFs, which are the short animated graphics that we see around the internet. And I want to start with a discussion of search, and then we will work our way towards the complexities of searching GIFs specifically. In order to build a search engine for anything, whether you're talking about search engine for books or products or whatever, you typically need to build a search index. Could you explain what a search index is?
Yeah, that's a great point. So in most traditional information retrieval systems, you're going to be building up an index. The idea behind an index is saying, instead of running through every single possible document or record and looking at the words in that, you're actually going to pre-process the information there. And that index is going to be a map of where those documents are. So if I'm looking at, in our case, a GIF, and the GIF happens to be tagged with the word cat, instead of having to scan through hundreds of millions of GIFs to find each one that says the word cat, we're going to have a tree, basically, and we're going to go down that tree looking for the word cat. And once we find the word cat, it's going to have an index of where each one of those is in our larger record set. So let's say there's 1 million GIFs that have the word cat. Then once I go down this tree, I'm going to have a list of those specific 1 million cat GIFs.
When I was in school, the typical way of querying against this search index, at least that I learned about in information retrieval class, was you have a query, and then the query gets turned into a vector, and then you try to match that vector in using some kind of like similarity measurement, like cosine similarity, against the documents in the search index, and then you can use that similarity ranking to order the search results. Is that still the way that search indexes are queried against?
Yes and no. So typically, cosine similarity with that kind of metric is It actually is used quite a bit, but most of the time, but actually in a way that's a more recent development. So, historically, you didn't have the luxury of being able to calculate cosine similarity or other such things on the distance. So you actually had to use the indexes to search for the documents. Now, when you're looking at, and so as a case in point, the traditional algorithms for this stuff are things like for ranking are TF-IDF and BM25. And let's say that I search for the word cat. I go down this tree, and it gives me a list of documents. Now, let's say that I've got a couple of these words. I'm going to combine them, and I'm going to look for the ones that have the most significance. So if I look for the cat, the reality is that I don't really, the truth is that a word like the shouldn't have as much weight in my search because, let's face it, it's good.
Stop words.
Yeah, exactly. Well, no, not even stop words. So stop words are saying different. Stop words are saying these words are just let's just throw them out, right? Beginning of the session.
Okay.
TF-IDF is saying that every word, even if it's not. So so stop word is saying this word is completely useless. I'm never going to look at it. TF-IDF and BM25 are going to say something like, if I look for Obama. I don't know, a weird phrase. Let's say I look up cat Obama. Well, and let's say that we have, let's say 10% of our GIF database is cats, but only 200,000 actually are tagged with the word Obama. The fact that it's so much rarer is an indication that the tag Obama should actually be considered much higher in that search than cats alone. So the TF-IDF is term frequency inverse document frequency. It's looking at that the relative unusualness of a particular keyword and trying to highlight those over a flat system.
That's great information. There have been some previous episodes about search that listeners can check out. But let's talk about GIFs more specifically. One interesting thing about building a GIF search index is that these are essentially unlabeled documents that are hard to label, or there's not a straightforward way to label them because they're just they're video file, they're graphics, and so theoretically, you would need to be able to associate some text labeling with them, because if people are entering text queries, then you need to be able to search against a labeling system that is commensurate with those queries. How do you get the GIFs labeled so that you can build a search index?
Yeah, so I'll cover some of it, and some of it I'll have to leave as secret source, but.
Mysterious.
Yeah, but one of the main things we have is there's a pipeline basically of how a GIF gets processed, and that's a combination of people inside the company, outside the company, tagging certain content. So sometimes we have partners who have professional content that their job is to bring in high quality content. And when they bring in that high quality content, let's say it's a TV show or whatever else, part of what they're going to do is provide that tagging, because to them it's very important that people can find the right content. Now, that allows us to do things like TV series, like let's say there's episode 2, season 3. Well, we'll probably have it. We'll have the show will be tagged as such. And the only way to find that out is really to have the people who build the content care about that. So partly it's an ownership on their side. In other cases, it's more automatic. So we have human and computer vision pipelines that tag images in the back end. And we expose some small fraction of that to the end users. But in our infrastructure, we actually support the ability to have many of these and leverage them in different ways behind the scenes for various types of searches.
It's fascinating how much this human in the loop kind of pipeline processing has begun to propagate to, I mean, what we do as computer scientists. I've done a bunch of shows recently about it. Recently, I did a show with Unbabel, which is a translation company, and doing translation with a combination of machine techniques and humans in the loop gets you a really robust translation. It seems like this is going to be a model for how we reduce ambiguity in complex querying, complex data sets, complex labeling for a long time to come. I mean, I think this is going to be like one of the things where if as things like warehouses and manufacturing get largely automated, this is going to be the blue-collar information systems work that is to be done, labeling and things like that.
Yeah, I think it's actually, you've kind of nailed it there. If you look at the history of machine learning, deep learning, any of these things, there's a great graph that got published a couple of years ago that shows the time when a new data set got released to the public and when major breakthroughs happened in that space. So, and typically it's, if I remember correctly, it's a gap of about 2 to 3 years. There is an argument to be made, and I personally am probably a believer in this, that the vast majority of breakthroughs that we see come from the availability of data and not necessarily new algorithms. Now, right now, and I'll get back to, but when we look at deep learning today, deep learning is an amazing field. But the truth is that a large portion of the work that we are seeing the fruits of today came from work that was done in the mid 80s to late 80s. Backpropagation, connectionist systems. This is work that was done in, I think the big book that inspired people originally was, I think it's called Connectionism. It was published in about 1986. Personally, it inspired me. I remember reading it in like 92 and being absolutely blown away by it. Now, and I've seen it referred to a lot recently because of the fact that it really was a big moment. But when you look at all the stuff we're doing today, a lot of it has to do with massive amounts of hardware. And we're running deep learning on huge GPU machines, thousands, tens of thousands, hundreds of thousands of machines that are optimized for this particular kind of problem. But often they're using the same algorithm. One of the big differences, though, is not only the computational power available, but it's actually the data itself. I can now, in a week, a couple of days even, actually, I take that back. I started this yesterday. In 4 hours, I can go from nothing to training a neural net on 1.5 million images with 10,000 tags. And 2 weeks from now, I can expect to actually have a fully trained deep learning model for that.
To understand how your application is performing, you need visibility into your database. Vivid Cortex provides database monitoring for MySQL, Postgres, Redis, MongoDB, and Amazon Aurora. Database uptime, efficiency, and performance can all be measured using Vivid Cortex. Don't let your database be a black box. Drill down into the metrics of your database with 1-second granularity. Database monitoring allows engineering teams to solve problems faster and ship better code. Vivid Cortex uses patented algorithms to analyze and surface relevant insights so users can be proactive and fix performance problems before customers are impacted. If you have a database that you would like to monitor more closely, check out vividcortex.com/sedaily to learn more. GitHub, DigitalOcean, and Yelp all use Vivid Cortex to understand database performance. At vividcortex.com/sedaily, you can learn more about how Vivid Cortex works. Thanks to Vivid Cortex for being a new sponsor of Software Engineering Daily, and check it out at vividcortex.com/sedaily. I think about sometimes we traditionally think of computing in terms of Moore's law, and I've been starting to think like it seems like as our systems have more and more emphasis on deep learning, it's less of a question of Moore's law, because this is not really something that's as much bottlenecked by a particular like processor architecture. It's more like, can you structure the problem in the right way? Do you have enough data? And because you can distribute all the computation, so it's not bottlenecked by any specific processor. Do you think is that accurate? Is that too wide of a statement?
No, I think it's very close to accurate. I mean, the majority of backpropagation algorithms in deep learning right now, there are variations. There's 2, 3, 4 different variations of stochastic gradient descent that are completely distributable, and the fact that that is available means that we can build incredibly complex neural nets and throw them against hundreds of machines, thousands of machines, whatever else, without really having to think about it too much. And the data winds up, which doesn't mean it's not slow. Let's face it, it is slow. It's a pain to train these models, but it is something very tractable.
Yes.
And the flip side of that is the data. So going back to the question around the human computer sort of workflow is that the biggest single issue you ever face in data science is getting a training set that's usable. So half of that is things like half of that is creating a structure which allows you to have enough samples, positive and negative. The other half is just creating a set that's large enough, and then doing feature extraction and all that stuff. And really, those are the things that are hard. And so you let's say you've got a couple of short videos. How do you get people to label things as funny? Well, can you build a machine learning algorithm that can actually learn funny? Well, you can argue that maybe the answer is no, but you could sit around all day discussing the theoretical aspects of it. It's a lot easier to do it and then throw it into if you can get that data, then you can generate that data, then you can throw it into a model, and maybe you'll get an answer that's surprising. But you have to have the ability to collect that data, and so a lot more work is now going into the creation of these data sets and the realization that, let's face it, a team of data scientists, however brilliant they are, unless they have a training corpus, don't really have the ability to build that much.
Yeah. Okay. So we have gotten totally off topic, like discussing like the abstract concepts of deep learning and human labeling, which is a fantastic, fascinating topic, and your opinions are very interesting. But getting back to Giphy, what are some of the hard parts of scaling a search engine? Because Giphy is, at this point, a search engine with a large API surface area. There's a huge corpus to be searching. Can you give me some description of what are the difficult parts of scaling that?
There's two ways to look at any problem like this. One is how do you achieve a final solution? And the truth is there's probably 1,000 different ways of achieving a final solution. The other one I think that's actually more interesting is how do you build a organization that can grow into that, and what are the fundamentals you put in place to grow a such solution? And to be more concretely, to sound less abstract about that, like what I mean by that is understanding that yes, we have a search engine. Now we have a fair number of documents. Let's say it's on the order it's in the order of hundreds of millions of documents now, or GIFs. The issue is going to be searching for across 100 million billion documents is a relatively trivial task. You can off the shelf you can do that pretty easily, and things like MySQL and Elasticsearch are well within the range of being able to handle that kind of size of a document. The question then winds up being, what is your service doing? What is it being used for? And what are the pain points? So for us, the biggest pain point is latency. We have very strict guidelines about how fast our API has to respond. So for us, the question isn't whether we can just respond. It's a question of, can we respond with a latency that's under optimally? Our latency is at a very, very rough level. We have a goal of under 100 milliseconds for any particular query. Now, in practice, that's a pretty good goal. If you're looking at a mobile phone, you've got latency from the network, you've got latency from various other pieces, and we can only control so much of that interaction. But at least we know that 100 milliseconds means that we're probably not going to be the bottleneck on a particular interaction with our service. So tracking that is kind of step one. Step two is tracking every single little piece that goes into that. If I don't understand the latency of hitting a particular application server from the edge, I'm probably not good. I probably don't have a complete picture of that. Once it hits our infrastructure, if I don't understand how long the latency is to hit a database or to hit a search cluster or whatever else, again, we're probably not in a good position to achieve that because we don't know how to optimize. So partly it's a continuous monitoring exercise, and like many other things, like you have to have internal goals that are adhered to and monitored over time, and you have to make sure that if there's something that's not monitored, you have it as a top goal in the company to add monitoring to that so that there's visibility around that. And if you see degradations, making sure that you quickly identify why and how to fix it in the future.
You're describing this trend in observability. Like observability is a huge topic of conversation right now. I had a really interesting interview with James Turnbull, who is the Etsy CTO, and he wrote a book called The Art of Monitoring, which is all about how to build good monitoring pipelines, how to do observability. Can you talk more about how you bake that into the engineering process, perhaps into the culture of, like, because search is such an interesting problem where you really want the latency to be good, especially when people now expect the responsive search or whatever, like where every time you enter in a letter it like requeries.
Yep.
So yeah, just discuss observability a little bit more.
Yeah. So, the book you mentioned it's a great book. I actually am a big fan of it. But in general, I think that what we've done to structure that, and I think truthfully the only way of doing this is that every group that is shipping code, it's effectively an evolution of the whole concept of DevOps. As teams, if you, again, stepping back a little bit, we had the notion of call it a systems group, and their only job, ops group, and their only job was to deploy code. All right, so we moved away from that. We got to this notion of infrastructure as code. Now, different teams had a little bit more control over pieces. And that's good, because people can deploy, people understand how things are deployed. There's a bit of a sense of the infrastructure underlying it. That got lost at some point, mostly around in the aughts. Now people are slightly more aware of the complexity and what the systems are running on. They're more comfortable with cloud. More people have exposure to some level of infrastructure and are aware of the fact that app code does not live or run in some abstract void. The next evolution to that has been getting an understanding of performance into application life cycles. There's the traditional adage of early optimization. Actually, I don't actually remember the adage, but early optimization obviously is a terrible thing to do. But the idea is really like how do you get people to ship code, understand, and then see it in production and be able to immediately identify what a problem is. So for us and for other companies I've worked in the past, I'd say 6 years, where I've made this a very integral part of routine, is every team has ownership of a complete dashboard that they can understand. So if I'm shipping a piece of web code, then as an engineer in that company, I need to be able to my requirement is that I should be able to understand how is that performing on the web, like what browsers is it, how well is it performing on the browsers, and have all that information and be able to set up alerts so that I understand if I'm tracking well on that. Performance should be part of the product management ownership. Like we should, that team should own latency, that team should own all those pieces. And more importantly, it should also own the ability to see when there are performance degradations immediately. So if I'm running web code and there is something slowing down the web, as part of that team, I should know about it immediately. I should be able to diagnose the problem, and I should be able to work with others to fix it. If it's in my piece of code, I should be able to fix it and deploy. If it's across the company, I should be talking to those people to understand a little bit more and help out on that.
This is like the Werner Vogel's quote, you build it, you run it.
Exactly. The idea is to provide the right tooling for people. You don't need to build the monitoring solution. You don't need to build the deployment solution, but you need to be able to you need to be able to have the tools necessary to be able to understand performance end to end.
Let's talk a little bit more about the infrastructure. Giphy is a search engine, but it's also kind of a budding platform. People can create GIFs on top of it. I imagine you have all kinds of interesting internal services as well. So I imagine you want to have a nice infrastructure that engineers can randomly spin up machines and run experiments and stuff. Can you give me an overview of how that's built out and like what cloud you're running on, and I guess just like how the culture and how the product has influenced how you built out that infrastructure?
Yeah. So the short version is we are traditional 2017 shop. We're using Docker. We are we've chosen Kubernetes right now as an underlying development and deployment platform. Because of the history of the company, and I think just because of the general nature of most modern companies today, especially ones like ours where we are dealing with so many different endpoints, we are effectively a polyglot organization. We have preferred tools for preferred things, but in the end of the day, we acknowledge the fact that no one language is going to rule them all. So to work around that, or to solve that, or to help developers with that, we're working with Kubernetes. As a developer, I can from a command line bring up the entirety. Within barring running out of memory, a miniature version of the entire stack or most of the stack on my laptop, and that's with 2 commands from scratch. And I can deploy my code into a new cluster in the cloud that gets auto-configured and everything else, again, with a couple of commands. The same infrastructure is used for continuous integration, is the same infrastructure is used for continuous deployment, and within the next couple of months will be used in production as our primary sort of cloud infrastructure platform.
Now, we are witnessing the growth in popularity, the growth in competitive potential of the Google Cloud, particularly driven by its Kubernetes features as well as the high-level managed services built on top of the Google Cloud that are differentiating. Though it seems that the Google Cloud has been, the rise of the Google Cloud has seen a lot of companies moving, well, I don't know about a lot of companies, but some companies at least, feeling comfortable moving towards a polyglot cloud world where we did a show with Meetup recently, and Meetup has a really interesting infrastructure where it's like a large percentage of it is on Google, and a large percentage of it is on Amazon, and it's actually copacetic. They're fine with that. So what about you? Do you have it centralized or anything, or you're just like Kubernetes on Amazon and you're hedging your bets, or what's going on there?
Well, right now we are running Kubernetes on Amazon, the truth is that we don't necessarily see a reason to have multiple cloud deployments at the moment. multi-cloud strategy is definitely becoming more prevalent. But really, the first step for any of these things is creating an abstraction layer that makes it irrelevant which cloud you're running on. And we see Kubernetes as being that solution. So, to answer your question, no, we don't have that strategy right now. But if there comes a day when it's like, yep, we definitely need to do that, we'll be in a good position to transfer.
But it does sound like you're using some of the Google APIs, like maybe Google Cloud Vision or some of these other higher level APIs?
No, actually right now we don't. Most of our CV work is done in-house.
Okay, interesting. Have you evaluated those options, or you just think they're too brittle?
Yeah, I mean, at the end of the day, most of the CV stuff out there doesn't perform all that much better than what you can download open source. Ironically enough, and I think maybe if you look at the absolute performance numbers, maybe it's like 97% versus 98%. But the reality is, for us, the majority of the time when we're looking at our content, we don't care that there is a plate in the image. We care that there is a happy face that has been made out of sausages.
Right.
And so, we have our own domain that we're training against and that we're working with that just isn't part of the equation for Google.
This is so interesting to me because that translation episode I mentioned that I did with Unbabel, they were talking about how a lot of the translation work they do is in the domain of customer service. Like you have a Zendesk ticket and they translate it into different languages, and so that builds their machine learning training model to be biased towards the domain of customer service, and so it makes it operate in a way that is much different than these one size fits all translation interfaces, like the ones that you can get as an API from Google off the shelf.
Yeah, I mean, and even Google's. I mean, originally it was. I believe the training set for Google originally was the transcripts from the UN.
Oh. Okay.
So I don't know what kind of bias that introduces, but it's got to be a little weird.
Diplomatic.
Yeah, very very diplomatic. No swear words, nothing like that. But and on the topic of swear words, it's kind of thing like we have. You need to train your model for the purposes that you are looking for. If I don't know that, if our models don't know that, well, I won't use swear words as an example, but if our systems don't know that hey with 3 Y's is not really the same thing as hey with just 1 Y, that it expresses a different emotional content. That's something that we need to capture, but perhaps Google doesn't.
Are you building any kind of graph structure that will let you relate different GIFs to each other?
I mean, I think the simple answer is we already have. I mean, if you look at tags, then you're already looking at.
That's true. That's implicitly a graph.
It is a graph, and we have some. There obviously we have lots of plans around it, but the truth is like where else can you go and find a GIF and say, okay, find me other, I don't know, Beyonce GIFs. That truthfully is the closest to a human, connected graph, that in many ways is out there.
So, this is kind of a weird question, but is GIF like a GIF search engine seems like the kind of thing where it's like at first glance it's like, okay, whatever, Google could just build this too, Facebook could just build this, like whatever, whoever could build this. But it seems like one of these things where like you start to look at the problem under a microscope and it's like this problem is actually way more complicated and takes way more engineering work than just somebody deciding, okay, we're going to stand up a team at Google to make the GIF search engine. Is that accurate?
I mean, I certainly hope so. But yeah, I mean, absolutely. That's I think there is an impression that it's an incredibly simple thing to do, and the reality is that it is an entire ecosystem. It's search. It's thinking about how people express themselves. It's thinking about how you identify content that is meaningful in different contexts and building the ability to provide that. And, there are similarities, like there's the word search, right? But like the truth, and I think we all fall into that trap of trying to find the closest analogy, but it truly is a different problem than anyone's ever dealt with before. And we wind up building, we're building a bunch of technology that is, truthfully, I've only been here 6 months, and some of the stuff that Giffy has had to build to be able to be Giffy is absolutely mind-boggling. And it's around understanding gifs, around manipulating gifs, around indexing, searching, working out the value of content, understanding what is relevant today, what is topical, all these aspects. Everything, you can imagine every single problem that Twitter, Google, and Facebook have ever had, all kind of combined under one, but hidden behind the scenes.
Incapsula is a cloud service that protects applications from attackers and improves performance. Incapsula sits between customer requests and your servers, and it filters traffic, preventing it from ever reaching your servers. Botnets and denial of service attacks are recognized by Incapsula and blocked. This protects your API servers and your microservices from responding to unwanted requests. To try Incapsula, go to incapsula.com/sedaily and get a month free for Software Engineering Daily listeners. Incapsula's API gives you control over the security and performance of your application, whether you have a complex microservices architecture or a WordPress site. Incapsula has a global network of 30 data centers that optimize routing and cache your content. The same network of data centers that are filtering your content for attackers are operating as a CDN and speeding up your application. To try Incapsula today, go to incapsula.com/sedaily and check it out. Thanks to Incapsula for being a new sponsor of Software Engineering Daily. It does defy analogy to previous services. It's not like you can say, oh, it's like YouTube because it's like videos kind of. It is like, no, because you don't frivolously message somebody a YouTube video to like the same way you would message an emoji. But people do that with GIFs, so it has such a different emotional valence.
Absolutely, and the emotional valence, depending on where you're using it and how you're using it, changes constantly. If you're talking to your grandmother, probably going to use a different set of GIFs than your best friend. And we need to be able to support that. And the language you use might change, but it might not change that dramatically. So how do you support that long term?
What about databases? How do you store the GIFs? There must be some level of complexity, like, as you could do stuff where, like, you want to make the first 2 seconds of or the first X frames of a GIF more accessible so you can preview it or something. I don't know. Can you give me maybe a description of the storage model?
Well, I could. I'm trying to think. Yeah, I mean, so that's when we start getting into some of the more interesting complexities. There are some very interesting storage models, both on the database side and the, on the database side, honestly, we're using scale-out solutions. The standard things you can imagine a company that needs to be able to scale out horizontally or across multiple data centers does. On the storage structure, I think that's actually one of the aspects where we have some very interesting proprietary work that we've been building out around kind of like how do you, what do next generation image and video pipelines truly look like? How do you move past like FFmpeg is a great piece of is a great tool, and everyone uses it. But at no point was FFmpeg designed to live in a massively distributed cloud system. At no point was it designed to have like sub sort of 100, 200 millisecond response times. And our infrastructure is being built around that, and truly creating as far as we know, certainly really the next generation of sort of low latency scale out image processing.
Yeah, and one thing I read about in some interview about Giphy was this thing called Giffy Dvr, which is sort of an attempt to tackle the problem of we've got videos all over the internet, but most of those have not been converted into GIFs. And in a perfect world, you would be able to query against Giphy for any GIF in any video that would be some substring or some concatenation of images in the video. And Giffy Dvr is the system where like you can put in a video and it looks through the video and finds plausible GIFs, like just basically it tries to, I guess, uses machine learning to try to figure out which of the areas in the video would be an interesting GIF. Is that accurate? Like how does Giffy Dvr work?
Well, I think that's you actually summarized it pretty well. I mean, if you're looking at a particular domain, let's say we're looking at like I don't know, basketball or something. If I have 4 hours of that, part of the goal is to create a system that can look at that and say, yes, here's 4 hours of the game, but here's the 16 6-second slices that you care about. And part of that is looking at, scene by scene changes, is looking at domain specific types of changes that will help you identify that. I mean, for example, if I'm looking at a sports game, having algorithms that understand that yes, there is a score. If I'm looking at soccer, and someone scores a goal, well, generally speaking, people don't score that many goals. So chances are that's going to be a big moment. And having algorithms that can use that information, sort of ambient information, extract those features, and create the system that automatically highlights the important parts of that. Now, when you have billions of hours of video, however many, I think it's probably billions of hours of video on the web and being created, and millions of hours being created every single day. That's the kind of infrastructure you need. And so when I'm talking about our kind of next generation image processing, it's really a combination of those things. It's the mechanisms that shape images, that transfer images, but it's also the infrastructure that helps run those kinds of algorithms at scale when you have enormous amounts of data being pumped through the system.
Let's talk a little bit about the team structure and the way that different teams work together. And I guess the place I want to start is there's kind of this interesting relationship between the creative team and the engineering team, I think, because as I understand it, Giphy, you have like a studio side, and the Giphy studio side is where you make GIFs and you potentially work closely with brands to get GIFs made that, it's like benefits the brand. It makes the brand look good, and people maybe want to share like a Snickers GIF, and it gets the brand some recognition. Can you describe how you structure the relationship between the creative side and the engineering side?
Yeah, I think we Giphy is a very interesting company. I think when you look at the background of a lot of the engineers and the interest of a lot of the engineers here, there is a strong artistic bent, whether it's actual art, whether it's photography, music, whatever else, and there's a very strong component of that being the idea that engineering should not be the standalone concept that never interacts with anything else. And I think, part of the ethos that we strive to keep is to make sure that there is a constant interest and respect and fascination with things outside of, did someone create a new algorithm that lets you sort numbers faster, and and says like, oh wow, here's a deep learning model that actually produces art. That's awesome. And creating that the traditional phrase of creating that culture of a sort of fascination of sort of exploration. I think with studios we are as a company, we are exposed to the amazing work they do every single week, and that they literally are presenting anything that they've created, anything that the artists there have done. And we have artists in residence, we have animators, we have there's a variety of different types of art being created there, and part of it for us is being exposed to that on a regular basis. For the engineering side is creating tools for them, and often and and one of the things we'll be releasing a lot more of this year is some of the incredible overlap between those two pieces of technology, the art, and the art of the technology. There's a lot of stuff that we've done, and we're actually very excited to release these kind of these incredible projects into the public. Some of them have been done in shows, so we actually have had several art shows in the last 6 months, even showing some of the sort of fun intersections of just on a purely technical level, I guess, on a computer level, websites and interactive art, but also physical installations that leverage GIF infrastructure, give a whole ecosystem around that to provide things that let you interact with animations and GIFs and stickers in the physical world.
I think that structure that you just articulated about Giphy is one of the first companies where I really feel like it's leveraging what you get out of being in New York, because there's a lot of talk about, like, is it better to build your company in San Francisco or New York? And one thing that's for sure is in New York, you're going to get more aggressive hybridization of, like, culture / media / music / art with engineering. There's a little less of that in San Francisco, I feel, and I think that's a real competitive advantage that Giphy has, and especially when you're talking about breaking down the silos between like advertisers and their fans, and kind of like the marketing messages, and like kind of the way that online advertising works right now, where you have like this church and state separation of who's making the advertising content versus who's distributing it. I think it makes me feel like Giphy is really well positioned.
Yeah, I mean, I'm certainly not going to disagree with you. I spent 2.5 years, I think, in San Francisco, and I've been around the country, and
more sterile.
It's a lot more sterile. Yeah, and I was, it was a great experience in many ways. It's being surrounded by other technologists, but I actually, I don't find it nearly as creative, and I don't find that people. I think the problem when you have too many people in tech thinking about tech is that you lose track of end users, you lose track of what you should be able to give back to the world as a product, because you become so entrenched in your own world. Ad tech has the same problem. If the only thing I care about is a click-through rate, then I don't necessarily know what message I'm conveying to the human beings on the other end. And I think that...
Not to mention you incentivize fraud.
Yeah, exactly. And the fact that you don't even know the difference, right? That's part of it. It's like you can have massive ad tech fraud, and the reason you can is because it's so decoupled from humans.
So exactly. This is something... So I've done a bunch of shows on advertising fraud recently. I've been thinking deeply about advertising fraud and where we asymptote towards in terms of advertising, because Google is an advertising business. Facebook is an advertising business. I don't want to see these companies go anywhere, but when you look at how problematic the state of online advertising is, I don't know, it kind of worries me, but I guess it will take a while for advertisers to sort of wake up and see how much of their money is sort of going down the drain, being viewed by bots and whatnot. I mean, have you thought deeply about the fraud problem, or do you have any thoughts on it?
Yeah, I mean, I don't know about. I mean, I don't know if I ever think deeply. I think with the fraud problem for us, is obviously it is actually a real concern, and partly because for us, if there is fraud, if we have people gaming our system, it will create a worse user experience. And for us, the primary goal of the company is to create a fantastic user experience. So fraud is something that we are incredibly concerned about for us, right? And we want to make sure that at no point do we get denatured by the equivalent of thinking of an ad tech, of a purely ad tech thinking. And I think we're well positioned, and I think we're in a great position actually to provide a more organic, healthier interaction for brands than has been possible with any of the ad tech world out there. So.
But is it a movement? Are we going to have a movement where advertisers are going to have to start to say, look, this is kind of a lost cause? Like, it's funny because we started off the conversation talking about observability, but the problem with ad tech is it seems like observability drives fraud, and maybe the solution is we don't observe very much, or we have some very crude high-level observability that is so high level that it's very difficult for any individual fraudster to take advantage of. What's this?
I would disagree then that I'm someone who believes fundamentally in sort of visibility and transparency as being the solution to these things. I think ad tech is the issue is not measurability. I think the issue there is the inability to measure the right things. I think, what will happen, I hope what happens is that we don't move away and we don't shy away from visibility and measuring because of the bad taste that gets left in the mouth after with ad tech fraud, but rather that we get better at measuring the right things that are truly indicators of how people are interacting with you, are interacting with your brand, are interacting with you as a company or as an individual, which is much harder, but I think much more valuable.
Well, yeah, and so to that end, are people making GIFs aggressively and uploading them? Because I know that is like kind of a side feature of Giffy right now. It seems like you're very focused on curating the GIF content and letting it be indexed, letting people send GIFs in messages really quickly. And there's you want to be able to send a GIF of Taylor Swift making a cute expression, or Kanye West doing something weird. What about the creative side? How much is GIF creation growing?
I think I actually don't have a clean way of measuring that, because what I see is we see GIF creation and we see GIFs as an art exploding, and we see people who in their spare time at lunch are, maybe they have jobs as a graphics designer, and at lunchtime they're creating amazing GIFs. I don't know if I can. I don't know if I can reveal the names. I think but it doesn't. The example I'm thinking of is a woman who created the most popular, most viral GIF for Obama last year. Actually, it was the most popular viral GIF last year, but it was for Obama. And it's a side job, but she does that, and she does it every day, and it got hundreds of millions of views. And it's the kind of thing where, as an artist, you're able to do that, and I think there is something where that is growing, and as it develops as both a form of art and as a form of expression, I think that will get increasingly large. We see that potential, and we see the adoption with things like Giphy Cam as being something where people are increasingly creating their own content, and sometimes they're sharing it, and sometimes they're publishing it, and sometimes they're leveraging all these things, we see a future where everyone has a set of GIFs, some of that they use on a regular basis, some of which are things that they created, with whatever panoply of tools we hope to see in the future.
What's the biggest vision, just to close off, what's the biggest vision for what Giphy could grow into?
I think the biggest vision of what Giphy can grow into is a little bit weird, but when you look at written word has a limitation in how much information it can convey. It's hard to convey emotions succinctly. It's hard to convey the depth. the opportunity for short form content is to provide the richest medium to express emotions, to convey a great deal of information, and to be able to augment how people interact one-on-one, to groups, and to communicate with a broader audience. If we are able to grow into all those things, then we can change how people communicate and provide a much better mechanism than anything possible today.
Anthony, that's a great place to close off. I want to appreciate you for coming on to Software Engineering Daily. It's been a great conversation.
It's been a pleasure. Thank you.
Listeners have asked how they can support Software Engineering Daily. Please write us a review on iTunes or share your favorite episodes on Twitter and Facebook. Follow us on Twitter at software_daily or on our Facebook group called Software Engineering Daily. Please join our Slack channel and subscribe to our newsletter at softwareengineeringdaily.com. And you can always email me, jeff@softwareengineeringdaily.com, if you're a listener and you want to give your feedback or your ideas for shows or your criticism. I'd love to hear from you. And of course, if you're interested in sponsoring Software Engineering Daily, please reach out. You can email me, jeff@softwareengineeringdaily.com. And thanks again for listening to this show.